Okay, now you can download your handout from my course view. So the topic that we're gonna learn this week it's called partial derivatives and the chain rule. And then if we have time left, we're gonna go to minimum and maximum problems in two dimensions as well. So the goal for today is we're trying to learn how to take derivative in two dimensions. So let's go. We're gonna first review how to compute derivative in one dimension first. So when you learn calculus 1, so you have fx equal to some function here. So let's suppose that you have fx equal to x cubed minus 2x squared minus x plus 2. You can take derivative here by using the formula that you learned in calculus 1. So differentiate x cube, you get 3x squared, and then minus 4x, and then minus 1. This is how you take derivative in one dimension. We take derivative, use the formula. Like this is the way we do. So another way that we can do is we can use the definition. So you can use definition to compute the derivative, right? So if you use definition, it's gonna be f prime x equal to limit fx plus h minus fx over h, where h go to 0. This is when you use the definition of limit, it's gonna be here. So basically it tells you that you start from the function fx and then you move from x a little bit to x plus h. So the derivative, the meaning is the rate of change. This term represents the rate of change because fx you go a little bit just above x, so it's gonna be fx plus h. And then once you compute this limit, it's gonna be derivative as well. So you can plug in everything and then you compute, so you're gonna get the same thing, 3x squared minus 4x plus 1. So this is the way that we can do compute the derivative. The first one is a little bit easy, right? So using the formula is always easy and handy, and it's easy to compute derivative by using the formula because you don't have to compute derivative by using the definition, so you don't have to compute limit and you don't have to do something complicated. But for using the definition here, this is a little bit complicated, depends on the function. This is complicated depending on the function you have. If the function is so tedious, it's gonna be, it depends on the function we face. If the function that we face, fx here, it's super hard, so it's gonna be very hard to compute limit, and it's gonna give you a hard time to use the definition. So there are two ways to compute derivative in calculus 1, using the formula or using the definition. And as you see in calculus 1 that we focus on using the formula because using the definition is way tedious, and then we are not going to use it unless it forces you to do by the question, or it's something that you cannot use the formula, so we're gonna come back to definition. Okay, this is the derivative in one dimension, the thing that you learn in calculus 1. So now let's start a new content. What is the derivative in two dimensions? You have seen it before when you learn differential equations in the clip, but we're gonna make it more formal here. Okay, let's go. So how do we define derivative for a function of two variables? So first of all, we're gonna just thinking this way. You have c equal to fxy. This is the function of two variables. Function of two variables. And then now we're gonna fix one variable to be a constant. Case number 1. If you fix y equal to y0, this is, you fix y to be constant, so y is a constant. So what happened is once you fix y equal to constant, so you're gonna have that c equal to fx y0. So y is constant now. When you fix y to be constant, this gonna come back to the function in one dimension, in one variable, right? So think of this way. So let's suppose that you have fxy equal to x squared plus y squared. If I say, oh, I plug in y to be one number, let's say 1, so you're gonna get x squared plus 1, which means it's gonna come back to a function of one variable. Then when it's come back to the function in one variable, then you can use the formula that you learned in Cal 1. You can use all the formula that you learned in Cal 1. So basically, the thing that you learn in calculus 1, you're gonna use it in calculus 2, because when we take derivative, we're gonna fix y equal to constant, and then you can take derivative because you can view this thing as a function in one variable. So basically, we're gonna do this. So the derivative of the function f with respect to x, this means you fix y to be constant. It's gonna be limit h go to 0. So you're gonna start from fx0 y0. This is going to be the point that you start, and then because you fix y equal to 0, so you move x a little bit from x0 to x plus h, and this is going to be the definition of derivative at the point x0 y0. This is the definition. So take a look one more time. So you start from fx0 y0, and then you take you look at the rate of change when y is constant. So you fix y to be the same, and then now you move x to x plus h. This is going to be the limit by using the derivative by using the definition. For case number 2, you can do the same thing, but this time you fix x equal to x0. So now x is a constant. So when x is a constant, so you differentiate with respect to y. So the thing that you're gonna have, it's gonna be limit h go to 0 as well. This time you start from x0 y0, and then you go to fx0 comma y0 plus h, because you move y from y0 to y plus h, because you fix x to be constant and then you move towards y. And then now you're gonna have the definition of the derivative. So we're gonna call this thing partial derivative. This and this, we call it partial derivative. So on the top part here, we're gonna call it partial derivative with respect to x. This is the partial derivative with respect to y. But keep in mind that usually we use the definition. Keep in mind that we usually use the formula. Not the definition. Because it is easier. To compute. So you can see that when you fix one variable x or y, so you're gonna come back to a function in one variable, and then now you can use the formula from calculus 1. And that is basically what you're gonna do when you take derivative. So we're gonna use the formula for from calculus 1. Easier than using the definition, but there are gonna be some case that you cannot use the formula. You have to use the definition. Okay, I will let you write it down on your note first, and then we're gonna do some problems. Let's see, maybe like 3 or 4 examples, and then we're gonna stop the class and then do something, return your exam, and then you can see what you did it right or wrong on the exam. So now we're gonna do example 14, 15, and 16 together. All right. So I'm gonna post this thing later, but I'm so behind on posting your clips because like last week I was super busy with grading the exam, so I didn't post the clip, but I will catch up later. So example 14, I want you to find partial derivatives for this function. So again, as you learned before, when you learn differential equation, you need to, when the question say find the partial derivative, it means you take derivative in two ways. So the first one, you take derivative of f with respect to x, and you take derivative of f with respect to y. So when you take derivative with respect to x, so it means you will y as a constant. So when you take a look at y as a constant, it means that you can take differentiate x to the fourth power. So you don't have to use definition, use a formula. So it's gonna be 4x cubed, and then this time 3x square y. This is going to be plus 6xy. This is because you don't differentiate y, right? And number 3, you don't differentiate, but you differentiate only x squared, so you get 2x, and then you group it up, so you get this one. And for y cos x, you're gonna differentiate with respect to x, so keep y constant, so it's gonna be minus, keep y constant, and then differentiate cosine, you get negative sine. And then differentiate sine y, you get 0, right? And then differentiate minus 15, you minus square root 15, you get 0 as well. So at the end, you have 4x cubed plus 6xy plus y sine x. This is super simple for this question. All right, when you differentiate with respect to y, so x to the fourth power, this is does not depend on y, so it's gonna be 0. And then here, it's gonna be differentiate with respect to y, you get 3x squared. And then here you get cosine x, right? Because y cosine x, you're gonna differentiate with respect to y, so you get negative cosine. And differentiate sine y, you get cosine y. And then the last one, you get 0. So it's gonna give you 3x squared minus cosine x plus cosine y. Alright, this is the derivative. Partial derivative with respect to x and partial derivative with respect to y. This is x is constant. This is a simple question. Another notation that you can use, f differentiate f with respect to x, you can use f and then subscript x. Here you can use f and subscript y, same thing. This is how we use the notation for this one. This is a very simple question for derivatives. But what you're going to learn next is you're going to learn how to use the chain rule in two dimensions. And then you're going to learn how to, what does it mean by derivative? Because in one dimension, you know that if you differentiate one time, set the function equal to 0, and then you can solve for max and min. But what is the meaning in two dimension? If you set derivative equal to 0 and then you solve the system of equation, what would you get? So we're gonna learn that as well. So this is the so today we're gonna learn how get familiar with the formula, and then you learn how to compute this one. All right, so far so good nah? So we're gonna move to example 15. Let's look at a little bit harder function here. X squared plus 2y squared square root x squared minus y squared, and then you differentiate with respect to x, and then you plug in at 2 and 1. So you can see that the function comes in the form of the product, right? So it's gonna be this thing multiply this thing, it's gonna be u times v. So that's no choice, you need to use the product rule. Because this one you have something inside depends on x and y. Something inside depends on x and y. So you have to use the product rule. So you're gonna differentiate with respect to x. So you're gonna get x squared plus y squared, and then you take the derivative of the second term, and then you plus the second term, and then you take the derivative of the first term, right? This is by the product rule. The product rule in calculus 1. Okay, so you need to use the product rule because it's come in the form of the product here. And then now again one more time, when you differentiate, you only care the term that's still inside the derivative function here. So this is already good. This is already good. So you need this one and you need this one. So differentiate this one. So if you feel like this is a hard time for you, you can delete square root and then you do it as a 1/2 here as a power. So it's gonna be 1/2 x squared minus y squared raised to the negative 1/2, and then you differentiate inner function with respect to x. So you're gonna get 2x. You follow that? This is like the function inside here. So you're gonna do the chain rule. It's gonna be in one dimension, it's gonna be 1/2 something inside raised to the 1/2 minus 1. And then inside here by the chain rule you have 2x because you differentiate inner function with respect to x. And then plus square root x squared minus y squared, the same thing. Okay, we have enough space. And then on the right, the last term gonna be the right hand side here gonna be just 2x, right? Because you differentiate with respect to x. And then you plug in everything at x equal to 2, y equal to 1. Or another notation is f subscript x 2 and 1, and then you compute it. So this is actually 2 square plus 2, and then 1/2. This is 4 minus 1 to the 1/2, and then times 2, and then times 4, sorry, times 4, and then plus 4 minus 1 times 4. So you compute everything, so you're gonna get the answer here, 6 times 2, and then here you're gonna get 1 over square root 3, and then plus 4 square root 3. So the answer is 12 over square root 3 plus 4 square root 3. But you can simplify it if you want to. You can stop here if you want to, but if you want to simplify, you can simplify it. Because you can multiply square root 3 here. So you're gonna get 8 square root 3 at the end. 4 square root 3 2 times, so it's 8 square root 3. Right, 12 over square root 3 is 4 square root 3. So 8 square root 3. So this is how you compute the derivative. So we learned in example 14 for the easy function, and then now we move to a little bit harder function because you need to do the product rule. Sounds good? Alright, so example 16. X squared y e. Okay, we're gonna just do this example. We're gonna differentiate f with respect to y, and then you plug in at 1 1. So here fxy equal to x squared y e to the xy. And then now you can pull out something. So you want to differentiate with respect to y, right? You differentiate this thing with respect to y. So it means x gonna be constant, so you pull out x. You pull out x. And then now that means that inside one that you still have it left inside the derivative, you have to use the product rule. So it's gonna be y, and then e to the x, y. You differentiate with respect to y, so you get x, right? Because you keep y, and then you differentiate e to the x, y, and then by the chain rule, you have x here, and then plus e to the x, y, and then you differentiate y, so you get 1. So at the end, you get x cubed y e to the x, y, and then plus x squared e to the x, y. And then you plug in at 1, 1. So it's going to be 1 times e to the 1, and then 1 squared times e to the 1. What is e to the 1? It's 1, right? E to the 1 is e, sorry. The answer is 2e. The thing that remind me is like, most of you don't know the value of e to the something. So you don't need to know the exact value of e. E is just constant. You can leave it as an e here. Some of you love to like plug in the number 2.71 or something like that. You don't have to. This e is e. It's good. But when it's come to log, log 2, log 1, this is actually a constant. I mean, log 2 is constant. That it is okay that you don't know log 2, but log 1 you need to know the value of log 1. Because some of you ask like on the exam that, can you give me log 1 value? Log 1 is 0, people. Log 1 is 0. This is like e to the 0 is 1. Okay. Alright, we're gonna practice. I hope that you already feel more comfortable with derivative in 2 dimensions. It is not that hard, but I mean, technically you can take derivative with respect to any vector in 2 dimensions. If you want to learn more, you can read something about gradient derivative. So you're gonna see that we can actually take derivative with respect to any line. Okay, so we're gonna move to the example that show you how to use the definition. So when the formula does not work, we're gonna use the definition. This is going to be our last example for today. So when the formula does not work, we're gonna use a definition. Let's try. So for example, if I have the function fxy equal to, let's say, something over x plus y squared, on the top maybe let me try to use a function that is a little bit harder. So I'm gonna just take a look at what I teach the Thai students, so I can use the same function. I think we did before with Thai student. 1 second. Yeah, let's check this function x cubed minus x squared y. Okay, let's do this one. X cubed minus x squared y. If I ask you to use the find the derivative with respect to x at the point 0, 0, this is the last question for today. What would you do? So when you do it, is that minus 2y? Minus x squared y, sorry, people. So if you use a formula, let's try to use a formula. Use formula. So when you use a formula, you're gonna have differentiate f with respect to x, right? So you're gonna get low here, d high minus high, d low over low square, right? So we're gonna keep the lower part and then differentiate the top part. So with respect to x, so you get 3x squared minus minus 2xy. This is low d high minus high, and then d low, it's gonna be 1, right? And then over low square. Can you follow that? This is low over high, right? So it's gonna be high, this low, sorry, This is a high one, this is a low one. So the formula is gonna be low, D high, right? D high minus high, D low. So it's gonna be keep this one and then differentiate this one, and then keep this one and then differentiate this one, the bottom part, and then you compute this thing. And if you plug in, you're gonna see that the denominator is 0, right? Denominator is 0. So it does not work. So it's mean the formula does not work. The formula does not work. So when the formula does not work, you're gonna come back and use the definition. This is the case that the formula does not work, so we're gonna use the definition. Let's see, this one I already plugged in at 0, 0. If I plug in everything at 0, 0, the top part gonna be 0 as well. So it's 0 over 0. Actually, you don't know what value it is, 0 over 0, so you have to use something else. So what we're gonna do when we use a definition is, so we're gonna just keep everything in one page. So we're gonna resize this and then do that, and then we move this thing a little bit up. Okay, so let's use a definition. Use definition. So when you use a definition, you're gonna say that, oh, differentiate f with respect to x at the point 0, 0. It's gonna be something like you want to compute limit. First, h goes 0. You take the rate of change on the top, and the bottom part gonna be just h. So on the top, you're gonna start from f0, 0. And then because you differentiate with respect to x, y is constant, so you're gonna switch yourself from 0, 0 to h0. Does it make sense? So it's gonna be something like, if you remember the first 5 minutes, I said that you have fx plus h, comma y minus fxy here. It means you keep y to be the same, constant, but x gonna move a little bit from x to x plus h. So here we plug in x and y to be 0, 0. So it's gonna be fh0 minus f0, 0. This is the way we use the definition. And then you plug in everything. So h0 here, you're gonna have h cubed minus h squared times 0 over h plus 0 square. This is what you plug in the value x equal to h and y equal to 0 in the function. And then here you plug in 0, 0. Okay, 0, 0 should be another function that here, because it is undefined, right? So you add more thing here. At the point 0, 0, it's gonna be 0. Okay. So add more on the question that you are going to use this function when x plus y squared is not equal to 0. But when x plus y squared equal to 0, it's going to be 0. So you can divide it here. 0, sure. And then over h. And then now the remaining of the question is that you need to compute this limit. So it's going to be limit of h cube, right, over h, and then you over h one more time. So h cube cancel with h, so you're gonna get h square, and h square over h one more time, you're gonna get limit of h. This is actually 0, right? Because you plug in 0 over there. So it means that by using the definition, derivative of f with respect to x at the point 0, 0 is actually 0. This is a question asked you to use the definition. It's a little bit tedious because you can see that even the function is something like this complicated, so you need to compute the limit super a little bit complicated, but when the function is more harder, it's like so more complicated, so it's gonna give you a hard time when you compute limit here. So basically we try to avoid using the definition unless the question asks you to do so. So mostly the question on the final exam gonna ask you to use a formula. Maybe just only one question asks you to use definition. So the way you memorize the definition is like you memorize that when you do the with respect to x, keep y constant, x gonna switch a little bit. But when you differentiate with respect to y, you're gonna keep x as a constant and then you move y a little bit from 0 to h plus 0, okay? This is actually the question that asks you to compute the derivative by using definition. Sounds good? All right, anyone have questions about how to compute a derivative? Mm-hmm.
So first, normally, as you said, that we should use the formula instead of the definition, if the function can provide answers.
Mm-hmm. So we need to use formula first. If you can solve it by using your formula, that's done. You don't have to go by derivative, definition of derivatives. Sounds good. The next part is interpretation of partial derivative, which we're gonna come back on Wednesday to learn something here. Let's give you a big review that this is the thing that you're gonna learn on about how to interpret derivatives. And then the next part we're gonna learn the higher the order derivative, which is you can differentiate one more time if you want to. It's gonna call second order partial derivative and so on. And then we're gonna learn the chain rule after, which is the chain rule in 2 dimensions. You need to draw the picture and compute the chain rule. And the last one that we're gonna learn is we're gonna learn that in 2 dimensions, what does it mean by taking derivative and then you get the maximum or minimum, because in 2 dimensions, in 1 dimension you set it equal to 0 and then you use the first derivative to check if it is a max or min. So in 2 dimensions, you're gonna do the same thing, set it equal to 0 and solve for max and min. But it's gonna be a little bit complicated because sometimes you're gonna see something like this. This is the saddle point, that this point can be max and min at the same time because it can be maximum on this side, it can be minimum on this side. So this is called the saddle point that you're gonna learn later for this class. We're gonna just use tomorrow and next week to learn derivatives, and it's gonna be a big part for the final exam, okay? All right. For the rest of the time today, so we're gonna give you the exam back, but I have not total the score, so you have to sum it by yourself because I'm just เครียดเหรอ